The good one, right? Or was it this one?
Try the other one. Red cap.
Yeah, much better.
If you need some more, try the other ones. If not, I got some in my bag.
Okay. So very good. Might have to break out the other ones. This one's
Yeah, all right. Try these.
I did earlier
Oh, you did?
when I came in. They're all kind of
All of them?
faded.
Here's three.
Okay, cool. All right, good evening. My name's Elijah, and I'm actually a doctoral candidate in chemistry at Florida Atlantic University. But when I started grad school a few years ago, I kind of caught the philosophy bug. So I've been studying philosophy on my own, ever since. And so I'd like to talk to you tonight about the philosophy of science. And I thought that maybe I could show how it applies to some topical issues in a nice way. So the philosophy of science, it's one of many philosophy ofs, right? Like there's a philosophy of music, philosophy of art, philosophy of a lot of different disciplines. The way it works, the best way I can think of it is it's kind of like, are you guys aware that you can be like a professional video gamer now? You can make a pretty good living, apparently. There's international tournaments. So I was thinking like, a scientist would be like the gamer, right? He knows the rules of the game, gets really good at playing the game, can play the game inside out. A philosopher of science would be like the game designer, right? He works on constructing the game, figure out what the best rules are for making a game. Now, the video game designer might suck at the video game compared to the best players, right? So it's not like being the one's better than the other. They're working at different levels in the same project. So that's kind of how I envision the relationship between the philosophy of science and science itself. So some of the problems that philosophy of science works on are things like what makes something scientific versus non-scientific, right? There's something we call pseudoscience, which is an idea that pretends to be scientific, but it's not. And so how do you tell what's pseudoscience and distinguish it from real science, right? Things like what makes a good scientific explanation, right? That would be under philosophy of science. And how does evidence support a theory, right? So if I didn't want to give just like a typical intro to philosophy of science, but if you are interested, a couple of names to look into are Karl Popper, W.V.O. Quine, and Thomas Kuhn. And these guys are just some of the major figures in philosophy of science. Now, philosophy of science is a 20th century thing. It's one of the more modern branches of science. But if you're interested in anything, do a deep dive into it. It's really interesting. But I wanted to approach this in a different way tonight. I wanted to talk about why philosophy of science and science in general is important. And so I wanted to talk about a buzzword that you may have heard on social media lately. It's called the post-fact era. Has anyone heard this talk of like we're now living in a post-fact era? So that's what people are saying, and regardless of how you view things politically, I think everybody should be disturbed by this, and I'm going to tell you why. But first, what is the post-fact era? People mean different things by it, but the best I can figure out is that it means that our trust in our sources of facts is broken down, right? Everyone assumes that the media and any source of facts are biased, so people are just like, whatever, I'm just going to believe what I want to believe. I'll believe the source of bias that matches my own beliefs, right? And it leads to a kind of relativism about facts. my facts are true for me, right? Your facts are fine for you, but I don't subscribe to your facts. It's a little bit similar to what people have been saying for years, that we live in a post-truth era, right? A friend of mine who's a grad student at Liberty University, right, and interested in theology is always concerned about the post-truth era, like people lose their faith and they don't know what the truth is. And so we were debating back and forth about what's a bigger problem, being in a post-truth era or a post-fact era. And it really seems like we're splitting hairs here, right? But I think it's a difference that's really important. So what are facts and what are truths? Or what is truth? A fact is what is the case. Right? If it is the case that it's like raining outside right now, then that's a fact. It's raining. The fact, if there's cats on the roof, right? There's a fact of the matter there. It's either on the roof or it isn't. We can figure it out one way or another. And the way we figure it out is by observing the state of affairs in the world that the fact is supposed to explain. Right. So a fact is what's called a truth bearer, meaning it can be true or false. So if I tell you that there's a cat on the roof, right, and you go out and check, and there is one there, then that's a true fact. Right. That's one theory of truth, is that it has to correspond to a fact in the world. So if I say something and there's a cat on the roof, and you go out and check and there's a cat up there, then I've said something true, right? It's the correspondence theory of truth. So a fact is hopefully something that's true, right? We're not interested in false facts. We're interested in what really is the case in the world. And one theory of truth is that it corresponds to the facts that are out there. So it's a little bit of like a chicken and egg thing. But people use the word truth in a lot of other senses, right? And they're not always just talking about the facts, right? People might be talking about moral truths, right? Values, value judgments. Or perhaps people are talking about things like mathematical or logical truths, right? There's a word in German called, if I'm saying it right, Weltanschauung. I'm sure I'm missing a... Anybody sprechen Sie Deutsch? Anyways, the Germans have a word for everything. It's one of the things you find out when you start studying philosophy especially. But it basically means worldview, right? And a worldview is more or less your entire collection of facts that you believe to be true and values, that you think are true, and everything that you put them together into a coherent picture of the world, right? So this is what people mean when they're saying we're in a post-truth era. It means that we don't all agree. We're not all members of the same religion. We don't all have the same political philosophies, right? We don't agree on a worldview, right? Now, we can live in a post-truth era, right? But I would argue that we can't live in a post-fact era. So one thing that, regardless of your worldview, we have to be able to agree on are the so-called concrete facts, right? The physical facts, the facts on the ground, so to speak. And this is why I think that, saying that we're in a post-fact era was really alarming. Like, you could tell me I'd say we've been in a post-truth era since, people started having disagreements about philosophy. But in a post-fact era, it's hard to proceed if we can't agree on the basic facts. So where do we get our facts? There are different sources, right? The ones that I think of as the major sources of facts are the media, the government, other people that we talk to every day, are our own senses, right? The things that we hear and see. Now, as I mentioned, we're in a situation where people are losing faith in the media, to tell them things that are true, or the government certainly, right? But the media isn't supposed to just make up facts, right? They're supposed to tell you their sources. And one of their sources is science. And I think that science actually provides a way out of the post-fact era. Right, so I'm going to be making my case for that. So I think what makes science special, right, as an epistemic system, is that we don't have to start with a worldview that tells us what facts to accept and what facts to reject, right? We don't have to know that our facts are correct right off the bat. We can start with facts that may very well be wrong. And in the end, using science will give us a greater or lesser degree of certainty in those facts. We'll know which facts to accept. So we have a method, in other words. That's the important thing. And you guys have probably heard the term scientific method, right? Right? Most people have heard of the term scientific method. It's actually technically called the hypothetico-deductive method. And this is what we use when we practice science, right? So there are 4 stages in the scientific or the hypothetical deductive method. I'll go through all of them. Right, the first stage is that we identify a problem. Okay, let me give you an example. We wonder what water is made of, right? We want to investigate the problem of what water is made of, right? The second stage is that we form a hypothesis. Does anyone know what a hypothesis is? Anybody heard the word hypothesis before?
I guess.
It's often called an educated guess, right? But I'm going to suggest an alternate definition of a hypothesis. A hypothesis is a possibly true fact, right? Or a group of facts about something. We're gonna throw one out there. We don't know if it's true or not, right? Our hypothesis is a possibly true fact. Okay, in this case, we're gonna have a hypothesis that says water is equal to H2O, right? 2 hydrogen atoms and an oxygen atom. That's our hypothesis. At this point, pretends we don't really know if that's true or not. It could be true, it could not be true. But that's our fact for now. We're gonna see if we can get more confidence in it. All right, so the third stage is that we look for the implications of our hypothesis. And what this means is, if our hypothesis is true, what would we have to expect to see, right? What are the consequences of it being true, right? In this case, if water is H2O, right, 2 hydrogens and an oxygen, then breaking it down should give us an equal amount of hydrogen gas and oxygen equal to the amount of water we have, right? So when we have their implications, then it's time to test them. That's the final stage, right? So the implication that if water is H2O, then it should break down into hydrogen and an oxygen gas, right? That gives us the experiment, right? So we do an electrolysis of water, right? We use electricity to break water up, and we happen to get the expected gases, hydrogen gas and oxygen gas, in the expected amounts, right? So does that mean that we know now that it's a fact that water is H2O? No, we don't know it for certain yet, right? We may never know truly for certain, but we can have greater confidence that it's probably true. It just went from a possibly true fact to a probably true fact, right? Now, the important thing to keep in mind here is that the key to all this is that we're trying to see if our hypothesis ever gets falsified, right? So why do we ever hear scientists talk about trying to prove ourselves wrong? Like sometimes scientists will be talking to the media and they'll say, the thing about science is we're always trying to prove our own theories wrong, right? Anybody ever hear that? So it sounds a little bit curious. Like what's the point of that? What are you trying to prove, right? Are you just showing us that, like, you know, you're so humble, you're questioning whether you're right or not? Or are you just masochistic and you want to see your theories crumble? Why are you trying to prove yourself wrong? Well, it's really important that science works by the process of falsification, right? So we're not trying to, like, do this experiment and then verify the truth that water is H2O. What we've done is we've shown that this hypothesis has survived an experiment that might have falsified it, right? Now, to illustrate this better, let's look at another example. How about the statement, all ravens are black? Anybody ever seen a raven that wasn't black, like a white raven or a blue raven? Every raven I've ever seen is black, right? But are they all black? This is a universal statement, right? This means that if this is true, it's true always and everywhere. Every single raven is black, right? You'll never see a white raven. How do we know, how do we come to know if this is true? How do we investigate such a statement? We can go look at ravens all day, right? How many ravens would you have to observe and okay, it's a black raven, that's a black raven. How many black ravens would you have to see out of all the ravens that exist before you can say all ravens are black? All of them, right? Not just all the ravens that there are today, but all the ravens that will ever exist, a potential infinite number, right? So that's not happening, right? But how many non-black ravens, how many ravens that are some other color, would you have to observe before you know that this statement is completely false? One raven that isn't black falsifies that universal statement, right? We can do that. If there is a non-black raven, right? If I had said all swans are white, people used to believe that was true. And then they found a black swan, I think in Australia, right? And falsified it, right? So we're always trying to look for what will falsify our hypothesis and then see whether or not we observe such a thing, right? That gives us a way to move forward. And I'll show you, if I can, with an illustration, just how you might think about it, right? You guys know Carl Sagan? No? Neil deGrasse Tyson? Well, Neil deGrasse Tyson at one time was a student of a guy named Carl Sagan. He was, you know the show Cosmos? That was originally Carl Sagan's show, right, back in the day. The one that Neil deGrasse Tyson did is a remake of it. So Carl Sagan was a great popularizer of science, right, as is Tyson. And what he said one time that I really like is that science is a candle in the dark. And this is the way I think of how the scientific method works with falsification. I'm going to draw a little candle here. Right. We can see just a little bit around ourselves if we're in a dark room, right, with a candle. So imagine this as the perimeter of light, and beyond it, everything's darkness, right? We don't know anything about what's out there. But we can come up with some conjectures and we can test them to see if they're falsified, right? And so we'll say, maybe this is what's happening, maybe that's what's happening. And all these arrows represent a different hypothesis, a different direction we could go, right? And one by one, we do experiments to falsify our hypothesis. And if the hypothesis is wrong, we cross it out. We don't go in that direction, right? And sooner or later, we'll find a hypothesis that is not falsified, and we'll say, okay, maybe we're onto something. Let's take the candle and take a step in this direction, right? And then we'll do it again. We'll look all around and say, okay, here's a hypothesis, here's one, which direction am I going to go? I falsify the ones that are wrong, right, by experiment, and whichever direction is still available to me, I just take a step in that direction. And in this way, we're feeling our way around in the dark, right, using the scientific method as our only guide. Now, eventually, our possibly true facts, right, become accepted facts. They become part of our scientific theory. Things like water is H2O are about as solid a fact as you're going to get, right? But always there's at least the possibility, right, at least a formal possibility that it might be overturned someday. We don't think it will. We have a high degree of certainty that it's probably true, but we'll never say for 100% that it's true, right? And that's the best we can expect. Right, that's how we know what we know about the world. And there's a view called pragmatism, right, that says that, well, I'm giving it in my own words, of course, but our view of the truth depends on how useful these facts are, right? The more useful the facts are to figure out how the world works, the more justified we are. In fact, that's our only basis to be justified in thinking that those facts are true. So knowing that water equals H2O enables us to do all this chemistry, right? And all these useful things. And it wouldn't act like that if it wasn't H2O. So that's how we are justified in thinking that, yeah, it probably is H2O, right? So that's the scientific method, right? And that's how we get our facts. It's the only reliable way to get facts about the physical world, right? So whatever your view of the truth is, I hope to have convinced you that science is the way forward in a post-fact world. Thanks.
Any questions for Eli? All right, guys, we'll take 5 minutes, and then who wants to go? Tanya, you want to next, or Jose?